All right, welcome to the lunchtime video. There's good news. We're moving on to a brand new topic today. So that's definitely very good news because I've got a lot more topics to get through. Unfortunately, I'm really not going to be able to get through all of the topics, at least not in this video format, before I take the test, if I can take the test. But we will keep doing the best. For a while, I wanted to do one topic a day, but that just turned out to be not possible. So I'm going to share my screen and then keep working towards this. So I'm sharing screen 2. And here's what I've done so far. Seamless MPLS, that was kind of a nightmare. Ldp tunneling, that was a great topic because I learned what the pre-requirements are for RSVP. It's of course a physical connection, layer 1, data link, everything good with that. Layer 2, so like your negotiation, your link speeds, that's got to be all set on layer 2. Now, where I kind of didn't understand is that you do need a layer 3, you need IP addressing setup. And additionally, you need something at layer 4. You need a routing protocol. I used OSPF in the lab, but when I had initially tried setting up RSVP, I did not know you needed configuration at layer 3 and layer 4, so I did not have IP addresses, and I did not have a routing protocol configured. Both of those two things are required in order for there to be RSVP traffic. All right, so next step is going to be Ldp tunneling. Okay, so we'll start the way every video is started. We'll do a help apropos. Perfect. So we've got lots of information for IPv6 tunneling. Let's just start off by looking at the standards. IPv6 over MPLS standards. Detailed information about the Juniper Network's implementation of IPv6 over MPLS is described in the following internet drafts. Internet draft, draft IETF, L3 VPN, BGP, IPv6. Yeah, I guess I don't need to read all that, but it's the BGP MPLS IP VPN extension for IPv6 VPN. And then we've also got connecting IPv6 islands over IPv4 MPLS using IPv6 provider edge routers. So that, I believe I covered that a little bit in my first series. Either that or that might have been some of the material I went through before starting this channel. All right, so we'll start off with this, or we'll continue on with this. Tunneling IPv6 traffic over MPLS IPv4 networks. You can configure the Juno software to tunnel IPv6 over an MPLS-based IPv4 network. So conveniently, we've actually already got an MPLS-based IPv4 network set up here. This configuration allows you to interconnect a number of smaller IPv6 networks over an IPv4-based network core, giving you the ability to provide IPv6 service without having to upgrade the routers in your core network. Multi-protocol border gateway protocol, MPBGP, is configured to exchange routes between the IPv6 networks, and data is tunneled between these IPv6 networks by means of IPv4 based MPLS. In IPv6 networks linked by MPLS IPv4 tunnels, routers PE1 and PE2 are dual stack BGP routers, meaning that they have both IPv4 and IPv6 stacks. The PE routers link the IPv6 networks through the customer edge CE routers to the IPv4 core network. The CE routers and the PE routers connect through a link layer that can carry IPv6 traffic. The PE routers use IPv6 core-facing interfaces. Note that one of the connected IPv6 networks could be the global IPv6 internet. So with terms like PE and CE, I tend to think L3 or a VPN. I don't have a VPN in my current topology, but hopefully that is not going to be required. Okay, so this is IPv6 networks linked by MPLS IPv4 tunnels. The two PE routers are connected through a MPBGP session using IPv4 addresses. They use the session to exchange IPv6 routes with an IPv6 value 2 address family indicator, AFI, and a subsequent AFI, SAFI, value 4. Each PE router sets the next hop for the IPv6 routes advertised on this session to its own IPv4 address. Because MP-BGP requires the BGP next hop to correspond to the same address family as the network layer reachability information, NLRI, this IPv4 address needs to be embedded within an IPv6 format. The PE routers can learn the IPv6 routes from the CE routers connected to them via routing protocols, routing information protocol, next generation RIP-NG or MP-BGP, or through static configuration. Note that if BGP is used as the PE router to CE router protocol, hello? Okay, so I am back. I just had I've got a dentist appointment during a pandemic, but I think most offices have been fine with that. Okay, so let's see here. Okay, I don't remember where I was. So I do remember. Well, let's just start. I do remember reading this. Well, let's just start from the top. The two PE routers are linked through a MP-BGP session using IPv4. Okay, that I remember very clearly. So let's start here. Each PE router sets the next hop for the IPv6 routes advertised on this session to its own IPv4 address. Because MP-BGP requires the BGP next hop to correspond to the same address family as the network layer reachability information, this IPv4 address needs to be embedded within the IPv6 format. So that's interesting. If you have MP-BGP enabled and you have IPv4, IPv6, different address families, L3 VPN, so you would need the next hop, because in a previous video we looked at how that next hop is sent through BGP. It's a value that's sent. It's not that it makes a calculation. It's not that it learns the next hop as it would for an IGP. For BGP, it carries the next hop with it. So you can have a router receive a BGP route that has just a total nonsense next hop. In fact, you can have it so total nonsense that you can have a next hop for an IPv6 address when you only have IPv4 on the network. So this is just a reminder that you have to have those address families matching in your next hop has to be in the same address family as neighboring routers. The PE routers can learn the IPv6 routes from the CE routers connected to them via routing protocols, Routing Information Protocol Next Generation, RIP-NG, or MPBGP, or through static configuration. Note that if BGP is used as the PE router to CE router protocol, the MPBGP session between the PE router and CE router could occur over an IPv4 or IPv6 transmission control protocol TCP session. Also, the BGP routes exchanged on that session would have SAFI unicast. You must configure an export policy to pass routes between IBGP and eBGP, and between BGP and any other protocol. The CE routers have MPLS LSPs routed to each other's IPv4 addresses. IPv4 provides signaling for the LSPs by means of either Ldp or RSVP. These LSPs, label switch paths, are used to resolve the next hop addresses of the IPv6 routes learned from MPBGP. The next hops use IPv4 mapped IPv6 addresses, while the LSPs use IPv4 addresses. The PE routers always advertise IPv6 routes to each other using a label value of 2. The explicit null label for IPv6 as defined in RFC 3032 MPLS label stack encoding. As a consequence, each of the forwarding next hops for the IPv6 routes learned from remote PE routers normally push 2 labels. The inner label is 2. This label could be different if the advertising PE router is not a Juniper Networks routing platform, and the outer label is the LSP label. If the LSP is a single hop LSP, then only label 2 is pushed. It is also possible for the PE routers to exchange plain IPv6 routes using SAFI unicast. However, there is one major advantage in exchanging labeled IPv6 routes. The penultimate hop router for an MPLS LSP can pop the outer label and then send the packet with the inner label as an MPLS packet. Without the inner label, the penultimate hop router would need to discover whether the packet is an IPv4 or IPv6 packet to set the protocol field in the layer 2 header correctly. When the PE1 router in the IPv6 networks linked by MPLS IPv4 tunnels receives an IPv6 packet from the CE1 router, it performs a lookup in the IPv6 forwarding table. If the destination matches a prefix learned from the CE2 router, then no labels need to be pushed, and the packet is simply sent to the CE2 router. If the destination matches a prefix that was learned from the PE2 router, then the PE1 router pushes 2 labels onto the packet and sends it to the provider router. The inner label is 2, and the outer label is the LSP label for the PE2 router. Each provider router in the service provider's network handles the packet as it would any MPLS packet, swapping labels as it passes from provider to provider, provider router to provider router. The penultimate provider router for the LSP pops the outer label and sends the packet to the PE2 router. When the PE2 router receives the packet, it recognizes the IPv6 explicit null label on the packet, label 2. It pops this label and treats it as an IPv6 packet, performing a lookup in the IPv6 forwarding table and forwarding the packet to the CE3 router. This section discusses the following topics. Okay, so that is that. Let's see if we can get, see if we can get a more clear instruction of what to do. So enabling IPv6 tunneling on PE routers. You can enable IPv6 tunneling by including the IPv6 tunneling statement in the configuration for the PE routers. This statement allows IPv6 routes to be resolved over an MPLS network by converting all routes stored in the inet.3 routing table to IPv6 compatible, so IPv4 compatible IPv6 addresses, and then copying them into the inet 6.3 routing table. This routing table can be used to resolve next hops for both inet 6 and inet 6-VPN routes. To configure IPv6 tunneling, include the IPv6-tunneling statement on the PE routers. You can include this statement at the following hierarchy levels. Okay, so it's going to be in protocol MPLS. So yeah, let's try to figure this out. So if I look at the configuration here, this might be a shorter video, but if I finish it before 12:30, I can even start a new topic. That'd be great. So here I've got LDP tunneling. So let's see what other options I've got there. Oops, I got to be in config mode. All right, so let's see here. Set. So this is going to be tunneling. So maybe there's under I or under T. So here's L. So we've got I. Don't see anything there. I see it for LDP tunneling. Okay, so it's not going to be under the label switch path, and that's what they actually said in the documentation. Here it is. So we can allow MPLS LSPs to be used for tunneling IPv6 traffic. So let's do that. Okay, so now we've got tunneling enabled. So let's test it out with an IPv6 address on the loopback interfaces. Okay, so I'm going to try a number of things so that I don't exactly understand how it needs to be configured. I'm going to try putting another host address in that same subnet. I don't think this will work. I think I will need to have them in different subnets, but I think this is worth a try. So it could work the way I don't think it will work. Yeah. Okay. All right, so let's try it the other way. Okay, so now hopefully this works. Okay, so we've got no route to host. So I thought what was going to happen is it would be tunneled, and we would get a route to host for the same reason we have a route to host. So if I do a show configuration interface all of 00, and I do show route 10.0.0.1, we have, oh, sorry, .2 for the other side. Oh, wait, what was the other side again? Oh, it's .6, the other side. So the same reason we have a route to host for .6, which is because it's in the INET3 table, so it can go into the INET0 table. I believed that we would have a route for this address as well. Yeah, but we've got nothing. So let's see. Show route advertising protocol. Oops. What are my options here? Okay. Okay, so it doesn't work that way. I thought it would be nice and easy and work that way. Maybe I could, is there, nope. Okay, it doesn't work that way. Okay, we're not receiving anything. We're not advertising anything. And it's not going to be protocol independent. So I think this kind of idea is really not the right idea. All right, I need to take a quick pause. All right, I am back. So let's try to figure out why that did not work. Okay, so I've got a loopback 0. I do have a route for it. Oops. Here we go. So I've got a IPv6 address on loopback 0. I do have a route for it. Oh, sorry. So I've got an IPv6 address on route on loopback 0, but I do not have a route for the other side. And I believed that I would because I have this enabled here for MPLS IPv6 tunneling on both sides. So I believed what I would see. Yep, and I've got it on both sides. So I would see a similar thing that I see if I do a show route 10.0.0.1 on this side and 10.0.0.6. So I believed that I would see something learned through OSPF and learned through RSVP, but it seems like actually you need a BGP connection. Let me pull up a third one and then read a little bit more about that, and hopefully I can understand more. I might need to do a Google search. Okay, so this makes sense. I remember this from a previous thing. I think what I may be missing is I do have an address here, but my MPLS interfaces don't have family INET 6. Now, they don't need an address necessarily, but they need to be to have the capability of transporting INET 6 traffic. And right now they don't, because the only families they have the capability of transporting is MPLS and INET. So I'm going to need to add that configuration on it. That's a really good one, because that would have, I think, kind of bit me during the exam. And not only that, I was able to figure that out through the built-in help that I'll have available to me. So really, really good stuff going on here. So, okay. And I'll add them to both. I believe they'll need to be added to both. All right, so hopefully we get results that are more what I was expecting. Nothing. Okay, so that was not it, clearly. Okay. Okay, I think I'm going to do a Google search. So you can see they do have that statement. So that was a piece of the puzzle that was missing, but unfortunately it was not the whole piece. Yeah, so this is what I kind of figured. I think it does require BGP to be set up. Now they're using LDP. I'm using LDP tunneled over RSVP. So that's one thing I can try, is just simplifying my configuration. Oh my God. Okay, so now I've got a much more simplified configuration. So this is the one that's left. Okay, so one thing I can do is, because they told me exactly what's going to happen, I can just verify that step by step. Now, hopefully the verification, yes, so there are verification steps here. So it looks like I require BGP. That's the missing step for all of this. Okay, so let's set up BGP, and hopefully that solves all the problems. So we won't need it on the transit routers. We just need it on these endpoint routers that we're going to treat like they're CEs. So let's set that up. Yeah, and I think it'll need to be external. I'm not entirely sure. Internal will need to deal with some different things. Okay, so it has a, okay. Huh. This is 120. So this is this address here. Okay, so the local address is going to be a bit different. It's going to be this local 1. Perfect. Okay, so here we go. So we're going to need something similar like that on the other router. Oh, but let me actually set a static route. Okay, and the destination we'll say will be 99:99 or ::99 / 128. And then we'll have it be eject and then install. Okay, so now we're going to need some similar config on router 1. Oops, we got a problem here. Invalid destination. Okay. Oh, wait. I think that's fine. What's so bad about that? Invalid destination or family. Oh, I see. I see. Okay, so what's going on is it's thinking that it's meant to be an IPv4 address, but I'm not sure how to tell it that I want an IPv6. Okay, this is interesting because I don't see a way to specify um, an IPv6. Nope, and I don't see anything for like family, INET v6, something like that. That just does not exist. So I have no idea what's going on. Oh, okay, I remember. God damn it. Ah, that would have killed me on the test too. That would have lost a lot of time to that. And it's this easy one. Okay, there we go. So hopefully, they, God damn it. Oh, it's INET.6, I think. Or .0. Oh, but the old one's still doing it. Oh, okay. Okay, hopefully this is good. We'll go with 9.8 for this other side. And then, of course, we're going to need to change the autonomous system. We're going to need to change a lot of parameters on this side. I might have gotten the neighborship wrong. Oh no, this is the local address. So, oops, it looks like here we go. Okay, yeah, I've got everything correct. So this is all I'm going to need. Let's paste it in. And I do have a Tuesday meeting today, I believe. So I'm going to need to wrap it up pretty soon. Oh, man. Okay, hopefully the table looks a lot better. Oh, we've got the 9.8, but we don't have the 9.9, so it doesn't look better. It doesn't look much worse, but it doesn't look any better either. Well, shoot. One thing I noticed is kind of strange is I added the route to inet.6. Oh, but it somehow figured out that it was 6.0. Okay, let's see if the BGP neighborship is up. Okay, and it is not, it is in idle state. Oh, you know what? I probably need a IPv4 BGP neighborship because that's the point. It's going to be tunneled over IPv4. Let's take a look at the example. Oh, nope. It is going to be an IPv6 neighborship. What's this? Why is it only on one side? See, I don't think I need this because I'm not going to have labeled unicast. I have no idea whether I need that or not. Well, it's got 5 minutes, so unfortunately I'm going to need to cut it there. So I might need to just scrap this whole thing or rethink it. Maybe in the next video, just go through and just do this lab here as is. I'm really not sure that this is meant to be configured without a VPN. You can see here the kind of VPN they are using. Oh, well, I guess they're not using a VPN either. So that's good news because I can go through this lab. I can see more what's different. I'm not going to kind of need to reinvent the wheel or whatever with how I had it before. So let me get my title for the video ready, if I may. Looks like I may not because my computer is lagging. There we go. That's better. Oh, man. Okay, here we go. So, yep, I'm going to need another video on this. I think that'll be fine. And hopefully I'll be able to figure it out. Okay, keys that normally do something on my computer no longer do that thing. I don't know why, but it's not really too much of an issue. Okay, so now let me get the tags. I can, let's put RSVP on there as well, and then IPv6. All right, so those are going to be my tags. Thanks for watching, and I'll see you in the next one.